not
We,
affected by outliers.
we used it. We used it in random forest model.
Okay, good. So
So it's a
used as
weak
a
learner.
Bayes estimator. Anything else? Okay,
So
so
decision tree usually are considered as weak learners.
yeah, that is okay. You can add that. Generally, weak learners, but this is true in the case of a decision stump, and a collection of decision stumps are used in various ensemble methods.
Yes, sir, like
Uh,
boosting.
yeah, like boosting and all. So it comes in this used as Bayes estimator. Any other points on this? It could be on its working, positives, negatives.
We cannot use gradient based methods here.
Okay, I think that comes in a bit of its working itself. For now, I'll not put the gradient part. Okay, I think I'll add one more thing that decision trees are very associated with is interpretability. These are some things. So tomorrow, if an interviewer asks you, can you explain about decision trees? Can you talk about its pros and cons? You'll go with something like this. These are pointers, but ideally you are going to give a more structured answer. So we'll briefly look at how decision tree works, like very briefly, and then we'll get to coding. So I can say that I'll probably have a question. This is my question one, so to say, and it can have two answers on whether or not it satisfies it. So it can be a yes, it can be a no, and here I can choose to ask one more question. I'll just put it as CQ2, and here it will be another CQ3, and then maybe this question differentiates the points enough. Like when I ask yes or no, maybe it separates the points enough. We are taking a binary classification setup where the labels yi belong to say 0, comma 1. So this setup maybe separates them enough when I answer yes or no that I can make this a leaf node. Okay, so if the majority is say one class, I put it as 1, otherwise something like this. Okay. So this is like the structure of the tree, and in this tree, what are some of the parameters that we see? So we will want to come to that. So while building the tree, maybe we initially had, let me use some other color. Maybe we had like 100 points here before we asked the first question. After asking 100 questions, maybe 70 went here and 30 went along this path. Of the 70, again, I make a split, and after splitting, say there are 40 here and 30 here. Now, the scalar implementation of decision tree has some hyperparameters. So one of them is this: how many samples should a node have if I want to make a split out of it? So that is your minimum sample split. And then there are also hyperparameters that dictate how many samples should be there if I want to call it a leaf node. So basically, if I have lesser values than it, say for example, after I make the split here, say once I make the split here to two leaf nodes, if this would have had very few points, then it would not consider this at all. It is not willing to make a leaf node and it would cut it off here. Along with that, some of the other things are maximum depth of the tree. So the more questions you are allowed to ask, the more there is a tendency to overfit, because for every single point it will try to optimize. Okay. And to split also, as we discussed, there are these different methods. You have your impurity calculations, and we want the best possible split, but it might not always be possible to get it. So this is a rough overview of decision tree. I'm sure you will recollect it. If not, you can again revisit this part in MLT and come back. So with this, we'll now move into the MLP implementation, or rather in sklearn, how we are going to implement decision tree. We'll first go a bit over the documentation and then we'll try it out on a data set. Any questions so far?
Hello, sir.
Okay. All right.
Hello.
Yeah.
Sir, at the leaf, how can we judge level of particular sample?
Sorry, can you please be louder?
Sir, at the leaf, how
Yeah.
do we judge a particular level of a sample, sir?
As in the height of the tree.
Yeah.
Are you talking about the class, like what class is given?
Yeah. What class?
Yeah, it is basically the majority.
Majority.
So, yeah. So, for example, I decide that I have some enough information gain. That is, the question that I have asked is separating the points well enough into two classes. And then once I separate out those 2 points, it's not necessary that every question that answered yes. Like for example, I say I am taking the biodata of students and trying to group them into classes. And one of the question was, is height lesser than 180 centimeter? Okay. And maybe my question is to put them into male and female gender. So when I say the height is lesser than 180 centimeter, let us say 70 points answered yes to it and 30 points answered no to it for height lesser than 180 centimeter. Of those that answered yes, now my separation target was male or female. So if it so ended up happening that it has, of the 70, majority of them say belong to one gender, and of the other 30 also majority of them belong to the other gender, then my question has separated things well enough. It has separated my target variable well enough. But at the same time, there is a chance that in that 30 also, say that 30 belong to the male class, male gender. Maybe there are few female points with female gender as well. So in that case, the label that we assign to that particular leaf node is just the majority. Okay. I hope it's clear.
I just want to understand more about a little bit about this impurity.
Okay.
Yeah, I completely forgot what is that.
Okay. So coming to impurity, so there is this idea of getting to pure nodes. Let me actually see if I can bring up the MLT slides. We can briefly talk about it, but yeah, beyond that, I would say we can go back to the lectures. Okay. So this is decision trees. This is from MLT. So here the prof has taken a data set x1, y1 all the way until xn, yn, where the xi belongs to some is a d-dimensional point and the yi is just nothing but the label that takes 1 or 0 in this case. So here we ask a question, depending on yes or no, it keeps splitting like this. And finally, we use this idea of information gain to measure whether a question is good or not. Okay, so based on this question, we have made this split. Now, a question is going to be a feature value pair. This is exactly the example that I was taking. So, is height lesser than or equal to 180 centimeter? So now, after asking this question, some points go on yes, some points go on no. And now the measure of impurity is nothing but how much, what is the purity of that node. Like for example, if all the points that answered yes were of one class and all the points that answered no were of the other class, then these nodes are pure nodes. Basically, there is no mix in between them. Impurity is whenever there is a part of the points belong to one class and a portion of the points belong to the other class. So this is this graph. Impurity is measured using entropy, and when all the points in that particular leaf node belong to 0, your entropy is also very low. When all the points belong to 1 also, your entropy or impurity is 0. If it is 50-50, half of the points belong to one class, half of the points belong to other class, as you can see, the entropy is maximum. Entropy or impurity. Okay. And the formulation for entropy is this one. Basically, entropy of P is given by minus of P log P. That is how many points belong to one class into log of that, plus the remaining points belong to the other class, right? So it is 1 minus P log 1 minus P. So this is one measure of entropy. And to get the information gain, we use this sort of setup, which is this is your root node. What is the entropy here? And after asking the question, how much entropy have I managed to reduce? So if these things end up giving very pure nodes, that means this will end up going towards 0, and this will be very high value, which means your information gain also will be more. Okay, it is a little confusing. What I mean to say is this is the parent node. It is impure. It has say 50 points belonging to one class, 50 points belonging to the other class. That means it is very impure, maximum possible impurity, because P is equal to 0.5. But after asking this question, all the 50 that belong to one class went on one side, all the 50 that belong to the other class went on the other side. So what happens when everything is 0 or 1? The entropy also becomes 0, which is why in this formula this becomes 0, this becomes 0, and entropy of D is nothing but the entire impurity that was there. So the information gain ends up being maximum. There are some other terminology, which is rather other parameters, which is gamma here, which is just to say indicate how many points went to each of these sides. So if a lot of points went to this side, then we want to weight the entropy on this side more. So something like weighting the entropy value. That's about it. Is this okay? Does this give a rough idea of what things are?
Yeah. The gain is basically how good the question is, and the
Correct. So
the
information
law,
gain is,
the law. What is that? The law. Not the law.
yeah, it is.
Any impurity is about how many questions we have to.
Yeah, so impurity is how mixed those
How
things
mixed,
are, and information gain is how well it manages to separate those into different classes.
Yeah. Thank you.
Yeah. So coming back to, I'm showing decision tree classifier here. Regressor also is something similar, that is there here. Some of the parameters will be the same. So we'll go over some of them that we are very familiar with. Max depth. So this is what is the depth of the tree. That is how many, like here, the depth is something like 1, 2, 3. So the depth is 3. So that way, how many questions I can ask is, you can think of that as the depth. And then minimum sample split. So this I told you, right? I took the case of an internal node with some 70 points. And this basically says how many points should be there if I have to make a split out of it. And the default value is 2. So basically, if you have 2 points, then I'm okay with you making a split. And the other is minimum samples leaf. How many samples should be there if I have to consider that as a leaf node? So now the bare minimum is there should be at least be 1 sample. Then I can call it as a leaf node. Apart from that, some of the things are, so this is again how good split is. We spoke of entropy. Some other methods that are there are Gini and log laws for classifiers. So same thing, if I come to regressor, there are a few different methods. There is squared error, Freudman MSC, and absolute error, and goes on. So these are again different criterion that you can use to decide on the quality of the split, basically. So split also there is different strategies. So you can either go for best or you can go for random. So by default it chooses the best one. Apart from that, there are some more parameters. Max leaf nodes is how many leaf nodes you want. Then there is class weights. This we saw in multiple algorithms. This is especially useful in the case of imbalanced data sets. Then one of you had mentioned about pruning. So the CCP alpha is nothing but cost complexity pruning. So this is also a value that you can set to cut down on the tree. So basically to prevent it from overfitting, pruning is one of the techniques that we can use. Okay, so this is again a brief use of the documentation. With this now let us directly get into coding for, let's continue with the same previous competition that we were working on. So let me just present the other screen. Okay. So once again we'll repeat this previous activity we had done. So this time hopefully you will answer quicker and can proceed faster. Firstly, what do I need to do? What is the first step? What should I write as a comment and what should I do?
Need to import the data set.
Okay, I need to import the data set. Uh, that is the files. Okay, and what is the code snippet for it?
pd.reads underscore c. Yes. Path of the
Yes, I can pass the path here. No? So we have train. Did anyone here manage to work on this data set? Anybody, can I get a show of hands? Okay, so do try to work on this. Let's go ahead then. So we have read the data set. What is the next step? What can I do?
Look the first 5 rows.
Describe
Sorry?
head describe and
Okay, head describe and what was the other thing?
is not null values.
Okay, so checking for null values. So let me say checking for null values. What is the code snippet?
Test dot is or train dot
Let's work on the training data. Train dot
is null
is null.
is
Is
any
right.
is any is any.
Okay. What else should I do?
Dot sum.
Dot
Dot sum.
null.
So what is my finding here?
There is no null value.
No null values.
Okay, there are no missing values in this data set. Okay. What next?
try to see the head to understand head describe.
Okay, so head, what does head do? What can I write as a comment if I'm going to use data.head next?
Features and looking at the features and
Okay, shall I say
target.
let us observe the first
Observe the features and
5 rows.
rows of feature and the features and target.
Okay. First 5 rows, features and the target. Is there any comment we can add here? So we discussed this last time. So what did we find out?
All the values are numeric.
Numeric and
Okay. We observe that all the values are numeric in nature.
Features are on different scales.
Okay, good. The features are on different scales. Anything else?
Redundant feature ID.
Okay, so ID is should not be part of the training. Yeah. Anything else?
Classification data sets.
This is the target variable is binary. The problem is binary classification. Of course, you can word this better. So this is just one quick. Anything else? Anything else you would want to write here? See, these are some nice points you all have come up with, and I would expect every time you all code, of course, unless it's not for the OPPs and all, but any time you are coding without time constraints, or it could be your job interviews, it could be some vivas that you are asked. Always make sure to write comments as to what you are doing and your observations of whatever you have seen. If you keep doing it, then you won't have to come back and try and read things again. Okay. Anyway, what is the next code snippet we can try out?
Train.describe.
Okay, so first tell me what it does.
It gives the summary of each feature in the data.
Okay, provides a summary of each feature in the data set. Can we say what kind of summary?
So descriptive statistics.
Okay, provides the descriptive statistics of each feature in the data set. And if you all are, say, you are presenting to some non-technical audience, or maybe people who don't directly know what descriptive statistics is, you can include things like something like which includes something like quantiles, mean, median. Mode, of course, median comes within that. Probably not mode. It has the max and min values and all, right? So something like that you can give it. So yeah, what can I write based on this? Do we see anything interesting?
Sir, days count to.
Sorry? What do we see? Anything interesting? Is there nothing we are gaining from this?
Sir, the variance means the spread of day is higher than other features.
Okay, the range. What did you say is higher for day?
Sir, the spread in standard deviation. Spread of
Okay,
the
standard deviation. So this is the other catch. The standard deviation of day is very high. But does this have any meaning to it? So think
yes,
about this.
yes, sir. It is showing that how far each data points are spread in the feature.
Yeah, so that is the
No.
other catch, right? So does anybody have
No,
any other opinion?
is it day one, day two? It will be having, right?
Right, so
Like
that's the
normal.
thing. So in the data set, it is day 1, day 2, day 3, day 4, day
Then
5.
it will be having this kind of
Uh,
a deviation.
so which is why you have a high standard deviation. So the standard deviation of day is very high, but this is
No meaning.
due to the presentation of data.
Oh, okay, okay.
So day 1 cannot be called greater than day 2. Basically, we cannot compare the days based on the values that they take like that. Okay.
Sir, we can say that there are no outliers in the data.
Okay. So there does not appear to be any outliers uh, on based on the above table. So what other methods can I use to find outliers?
Sir, box plots and techniques like five numbers. No. IQR.
Okay. So box plots, this could be verified using box plots, IQR based formula. Also something called as isolation forest. You can look up. Okay, something like this. Any other points that you will see? Anything about the scale? Nothing interesting about the scale, is it? Okay.
Yeah, the features are having different scales.
Okay. So that is true. They are having different scales. So most features uh, have scales that are closer, but pressure has a vastly different scale. Okay, so this can be phrased better again. So most of the features range between say what here minus zero point 0.3 to something like okay the maximum is also 300 in terms of wind direction. Whereas your pressure it starts itself from 999 and goes up to 1034. So that is a very clear difference. Which of your modules will be affected by scaling? I asked this in the last session. Did any of you have look it up?
Sir, KNN and linear regression and SVMs also.
Okay, good. And what about decision trees?
They are not affected by scales.
Okay. So that is one thing we'll keep in mind and we'll test out today whether scaling helps or not. Okay, good. Anything? What is the next code snippet I can try out?
We can split the train and test.
Okay. Before that, can we do any other exploratory type things?
Info for the
Okay. So what does info do?
info will give all the details.
Yeah. What kind of details?
Features. Explain the detail.
Like the counter features, any null values,
Okay.
data types.
Data types.
Let us observe the data types of the features, presence of null values, and count of number of rows. What did we find here?
All on
Day
No,
ID
no null
range.
values.
Okay, there are no null values. Anything else?
Integers.
And data is float and int type.
Okay. So can I say that? So we already wrote about null values, but again you can say there are no null values. Most of the features, and then all of the features are numeric in nature. Okay, once again we have sort of confirmed it. Okay, what is some other next code snippet? What can I write?
Sir, pair plot.
Okay, pair plot. What else?
Sir, will value count be useful here?
For which column will we use value count? Which of these would you want? Should we try it out on? We can use it on one of them. One of them actually it would be quite helpful to check it. I want a reasoning as to what we can use it on.
Sir, we can use value counts in rainfall to check is the dataset is imbalanced or not.
Very good. That was one of them that I was looking for. So, what is this? Let us observe if the data set is balanced. So, what should I use? What is the code snippet? So, what is the observation?
Is imbalanced.
Okay. Anybody, any other answers? No other answers?
Now, how do we say this is imbalance?
Okay. So, in this particular case, we can see that there is 25% belonging to one class and the remaining 75% belong to the other class. So, there is definitely an imbalance. Usually, this is more of heuristic based and something that you would see previously, like historical trend based thing that you make an assumption. But your highly imbalanced data sets, this is imbalanced in the sense that there is 25-75 split. Usually until 60-40 also it is okay. Beyond that, it starts becoming a little imbalanced. And the ones that are highly imbalanced are the ones like your fraud detection data sets. Basically, where the number of frauds committed as to the number of genuine transactions, it ends up being like 5% or under 1% sometimes. So those are your highly imbalanced data sets. But otherwise, you would have to check historical data-wise what does it say. So in this particular one, we can say this is somewhat imbalanced. I will say the data set is slightly imbalanced.
So, sir, if it follows some 80-90% of the class balancing, then we say it's highly imbalanced.
Right.
Okay.
So there is, it is more of again, it depends from a case to case basis. So when you have 90% belonging to one class or even 80% for that matter, there is a strong imbalance. And it will require us to deal with these things carefully. Now there is imbalance, but it is not very bad as well. So we out of 2000 we have 500 points. At least 25% we have belonging to the other class. Okay.
Okay, sir.
So yeah, what can we do for this? What are some approaches?
So means to get rid of from the problem of imbalance.
Yes, to deal with imbalance,
Yes.
can you give me two approaches?
Yes, so sir, we can do oversampling or undersampling. In oversampling, we can use SMOT,
Okay.
or we can either use class weight, where the lower lower number of samples class is given more weightage from the model by the model.
Very good. So here we can use oversampling, undersampling through methods like SMOT, and the other is make use of the class weights parameter to within the model, something like this. Okay. So yes, then I had heard pair plot. So what is the code snippet for pair plot? Anybody? Any answer for pair plot?
So can you please repeat what you said?
No, I was saying pair plot. For someone suggested pair plot as one visualization method. So let us. What is the code for pair plot?
Oh, pair plot, sir. SNS dot pair plot give the complete data.
But I just write train here. What else? Let's see if we can cover it or rather color it based on. Let's do it without the hue and let me add color.
Sir, hue is used to check another type, means if we want to check scales, means the distribution of data, but we want to add another information about the target variable, then we add hue, I think.
Yeah, something like that. So we can basically have this sort of coloring to it where it will kind of give us a separation if there is any separation based on the target variable. So
Yes,
hue
yes,
is an additional parameter that you can feed in.
yes, and it gives us also additional information.
Correct. So it
Yes,
can help you see if there is any clear separation for the features based on the classes.
yes. Okay, sir.
Okay. So in the meantime, let's see if we can go ahead. Okay, it is here. So this here, now currently I'm going to leave it at this. But one of the things that you all will have to do when you are trying out on your own is go for a smaller subset. Ones that you think will have a strong relation here. See, some of them clearly seem to have a relation. Yeah, it is like temperature and max temperature. So it's expected. So there seems to be a strong correlation between some features. And so it's a good idea to plot this in a different way. Okay, so that I'll leave you all to explore. So with that, what can I do for correlation? How do I get the correlation? What should I do for that?
So SNS dot heat map, and then train dot coara.
Is there anything else I need to put?
Sir, we can put not equals to true to get the correlations values in the cross tab itself.
Good. So what if I had categorical variables? Will this code still
Numeric,
work?
numeric tools.
Good. So here we don't have any categorical variables, so I'm assuming this should work as is. Okay. So this is this one. Let's see if we can. Hoping this should work. What is
Sir, it is PLT dot figure in brackets. It is figure fig size.
Okay. Sparse length.
Sir, it is figure.
Okay, it's not directly fixed size. Let us see it in. There's probably no underscore maybe.
Yes, sir, that's it.
Okay, great. Let's see if we can increase this size.
Sir, I think this should be above the heat maps code
Right.
under yes.
Okay. Good. So this is a better visualization. Maybe this is too much. Can't see it in the screen. Okay. So do we see anything interesting here? Are there any values that directly grab your eye?
Which is light color, correlation is high through
Okay.
seeing the colors, and which is darker color goes to the negative correlation.
Okay.
Maybe.
So let us just focus on maybe the rainfall, the target variable. For now, can you tell me some important points from this?
So
Based on the last
heat,
row. Yeah.
okay. Actually, sir, the heat map was not visible clearly.
Yes.
It's still not visible, is it? No, I'm saying use this last one only.
Okay, sir.
So based on this last one, you tell me.
Rainfall and sunshine is negatively correlated.
Okay, rainfall has a negative correlation with sunshine. So if you have to tell it to a non-technical audience, how would you phrase it as? If he doesn't know what the word correlation means.
With cloud, there is highly correlated rainfall with
Cloud and
cloud and
humidity.
humidity.
Okay. Cloud and humidity
Direct relationship with the rainfall.
have a positive
Positive correlation.
correlation with rainfall. Okay, again, say I don't know what correlation means, then how would you describe this to me?
Yeah, for example, we can tell that when there is a high rainfall, then there is no sunshine, or
Okay.
when there is sunshine, there is no rainfall.
Higher the rainfall, and let's go with the other way around because rainfall is a target, right? More the sunshine, lesser the rainfall. Okay, something like this. Of course, you can again phrase it better, but this should again be the idea. Wherever possible, try to include statements that are not sounding too technical as well. So we have the correlation plot. What else should we do? What can we do next? Answers.
Sir, plot box plot of each feature. We can check for the outliers.
Okay. So what is the code snippet for it?
PLT dot no SNS dot box plot, and then
Okay. So will this work for each feature?
for
What are the
that, sir,
parameters?
actually for each feature we'll have to run a for loop, but for one feature we can simply put train and then square brackets and the feature name.
Okay. So what should we print it for? Let's pick, let's say temperature for now. is okay. So what do you make out of this? Are there any outliers?
No, they are not outliers, but the dataset is skewed towards right.
Yeah. Okay. Cool. That is valid. So mostly the values start somewhere below 20 and they end somewhere below 30 in your for your 25th, 50th, and your 75th percentiles. So this is our general observation of this. We can verify this with what we saw in df.describe. Temperature, the 25th is below 20 and the 75th is just below 30. Maximum is 31, minimum is 7.4, which is kind of what we end up seeing here. Okay. So that is
Sir,
box
can you
plot.
plot,
Yeah.
sir, can you plot disk plot for more understanding of the skewness of the data?
You want to see the distribution.
What, sir?
Do you want to see the distribution of the data set?
Yes, sir.
Okay, so for this, I would say there are, of course, multiple methods. You can use violin plots, you can print the KDE. So there are many such visualizations you should go for. Ideally, I would recommend go with all of them. But for now, yeah, I would say we'll proceed ahead. But yes, by all means, explore both from Matplotlib as well as Seabot. Okay. So yeah, we can use any of those. We can see the distributions as well. And we can see scatter plots between features to again observe their correlation, something like temperature and minimum, maximum, things like that. So now we'll go ahead with our model building. So for that, what should I do first? What is my next step?
Train to split.
Okay. So from a scalar, where is train test? What should I write now?
X train, Y train, test, Y test.
Okay. Will this code snippet give an error or will it be fine? Are we
Sir,
missing something?
Sir, we haven't separated the targets, sir, from the features.
Good. So, how do we do that?
iLock or drop.
So, is this okay?
Yes, sir. I was wrong.
Okay. So, what should I write here?
X comma Y
Okay.
plus size.
What does random state do?
Try to keep the same.
Right. So, if I keep repeating my experiments also, I should end up getting the same result. So, this is for reproducibility of an experiment. Okay. Now, what is the type of my data set?
Since this is imbalance, we should not stratify or something.
You can use stratified shuffle split as well. So this time let's go ahead with this. Let us see the. So that is again a very good thought. So you can go with these different approaches. You can see what kind of split it has ended up giving. So if it looks okay to you, you can go ahead. More or less, the ratio seems to be quite similar. So 3 times. So this is also again 3 times. So we are okay with it. Okay. So here I can give a comment. We split the data set to obtain a validation data set. What does validation data set help in doing? Why do we do this? Any answers? No?
It is used for hyperparameter tuning and cross-validate in different ports. Like if we give one one part of the dataset, whether that part is performing well, or we can do like from the cross-val score or cross-validate
Okay.
class.
So shall I say in general this helps us to generalize to unseen data better. Prevents model overfitting and things like that, or at least helps us check for it. So we have now made this split. Yeah, let's actually directly go with the model building this time. Let's build on model. So I want to build a decision tree classifier. What should I do? In which module is decision tree classifier presented?
From sklearn.tree import decision tree classifier.
Okay. I'm using the basic parameters. What should I do to train and check?
Model.fit x
Okay.
y3.
And I would like to evaluate it on. I would like to see its performance on multiple evaluation metrics. What should I do? Yeah, is there a question?
So here we are not scaling because decision tree is not impacted by.
We'll get to that. So we'll test it. But yes, in theory, decision tree is not affected by scaling.
Okay.
We'll come to it. So let's see the performance of this model. What should I do? I want to check its performance on multiple evaluation metrics.
So pre-processing and import cross-validate.
Yeah, we'll do cross validation. But now I've fit my model, and I just want to see how it does on different evaluation metrics. So tell me what are the different evaluation metrics?
Yes, we have accuracy score, precision, recall, F1.
Okay, evaluation metrics involved in classification problem include accuracy, precision, recall. What else?
The F1 score.
F1
Oh, F1. I'll put these now. There are some more that you have to be aware of. Now, where can I get all these values? Should I individually have to import all of them?
Metrics, sir.
Metrics.
Okay, it is in
So-
metrics.
So,
What should
so
I
we can
import?
use classification report.
classification.
Can go for classification report. So now what should I do to get the classification report?
So predict and put the vibrate to classification report. Vibrate and white test.
Okay.
To give white X test.
Sorry.
Now we need to give classification report. White test.
So what should I do to make this come properly?
Print.
Good. Okay. So what are your thoughts based on this? What are your findings? No thoughts on this, sir?
So because of the class imbalance, the precision and recall means where the type 1 and type 2 error are the model is making type 1 and type 2 error. That's why the precision and recall and also F1 score is less, but the accuracy score is high. Accuracy score is higher.
Okay, so can we say the performance of the model varies for the two classes and the metrics corresponding to class 0 are poor, though there is a higher accuracy overall. So we have one finding. And how many total points are there in the test data set? In this Y test, how many points were there based on the classification report?
400 plus
438.
So there were 438 points. 111 of them belong to class 0 and 327 to class 1. So how do I see how many points have been misclassified? What should I do for that?
confusion matrix.
Okay. Okay, so we have this by test and a prediction whereby PRED model was called
Sir, dot plot. Sir, dot plot.
yeah. Okay. So how many of the points had a true label of 0, but the model has misclassified it as 1?
43.
The true label is 0, model has misclassified as 1.
51.
51.
Yes,
51,
51.
right? So you see a true label 0. So 68 plus 51, which was nothing but your 100 and whatever value we saw here, 11. I mean, it will not be just this. It will be, yeah, this is a true label, so it should have been matching. Why is it not matching? The other number is also not matching, right? Let's do this. So 8 plus 51 plus 43 plus 276. Okay, there are 438 points. What mistake are we making with the two labels? Okay, this has become the other way around. So 68 plus 43, this is 111 and this is 327. Yeah, so this has come ulta here. Did we end up giving this reverse? Yeah. So did you all realize the mistake?
Yes, sir. Yes, sir.
So the classification report takes Y true first and then Y prediction. So we have given it the other way around. Okay. So now the actual number of points in 0 were 119 and in 1 were 319. So now if I count 68 plus 51, there's 119 and this is 319. Does it make sense now? Is there anybody who did not get what happened? Okay. So that is again important. So there's a good chance your code will run, but you end up doing some mistakes like we saw now. So we need to be careful about it. Okay. So with that, now let's try a different model. Or rather in decision tree itself, let's do an experiment from a scalar dot reprocessing import scalar.
Sir, can you share the link of this toggle? Sir?
Sorry?
Can you share the link of this toggle?
Yeah.
And will be able to see this code?
This code I will not make it public. But yes, see, what I want you to learn is the general principle. So whatever we did in today's session, I want you to try these things out on your own. You don't need to follow the exact same code snippet. Think on your own, look up resources. You know the general plot. So we have discussed it multiple times. Pre-processing, in that what functions come, visualization, which ones come. Then, so try out all these things on your own. So even if one of you had done your work on this today, we would have gone through your notebook. So which is why I'll say before the next session. The next session is on Thursday. So before that, I want at least a few of you to work on this, and together we'll review our notebook and we'll see how we can improve on it. Okay. Do give attention to. I've shared the link of the competition. Do give attention to things like comments, your analysis, and all that, and see if you can get good scores and get a good leaderboard position as well. So
Sir, can you please repeat what you said?
Yeah, I was just saying, participate in the competition, in this particular competition. The next session is on Thursday, and create your own notebooks with code and comments and analysis, and we can go through it together. So, okay. I'm audible, right? Is there any issue with my voice?
No, sir. No.
All right. So, yes. What should I write here? Is it the same code?
Scalar transform.
Okay.
Only transforms.
Good. Now here actually let's do one change. So let's see the parameters taken by random decision data. So these are the parameters. Yeah. So there's a random state. Let's actually set the random state. This time again with prediction. Okay, there is actually a slight difference. So 68, 51, 43, 276 was there. Now we can see it is slightly different. just from changing random state, so it's nothing very serious. But now we have scaled our data. Let's train model 2 now. Actually, let's just try it with the previous model. Let's copy the entire thing. It takes a custom. Okay. So let's do a model dot get transform xtrain comma xtest. Okay, what mistake have I made here? I've made some very random mistake. Can someone tell me what I've done wrong?
So these model dot fit x train x test y test y train, sorry.
Yeah, it was just a very
Right.
random. This one. So we've got this. Now let's get the predictions. Okay. But do we see any change in the scores? 0.64, 0.59, 0.61, 0.64, 0.59, 0.61, and 119 points. So the same values, right? Let's maybe plot the confusion matrix as well.
I have some basic doubt in this transform thing. For this.
Yeah, please go ahead.
Why do we do this fit transform only for the train and then transform only for the test?
Okay. So what we're doing when it comes to fitting is you're learning some parameters, you're learning some weights. So which is why, like, think about the linear regression model that you might have built. You're learning that set of weights.
No,
right?
but standard scalar, it's only scaling, right? There is nothing happens.
Yeah. With standard scalar, you can even just. So there is this even in these preprocessing methods also. Like for example, let's take encoding. So you want to know the things that are there. You want to know the different kind of values that your features will take, and then based on that, you are making your transformation. So the idea of using fit is only required whenever there is something that you need to learn from your training samples, and then use that to make the transformation. So in those cases, you need to make use of fit transform. Is that okay? Okay, let's go to the documentation.
My understanding is standard scalar, it just
standard scalar is just a transformation.
Subtract the mu and then divide by standard.
Yeah, so it is just a transformation. But to make this transformation in standard scalar, you need to know what is your mean and your standard deviation. So which is why the training data that you have, when you do this, you find out those parameters. And then you make the transformation. Now, the reason we only do transform for test is because we don't want any form of data leakage to come. Because in practice, we'll have no idea about what a test data is until we see it. And whenever we do fit, we are learning something about the data. So we have gotten the information about the mean and standard deviation. Right. Hello, is it clear now, or do you still have doubt on this?
I think I need to
Okay, so
still need
see,
because this is a pre-processing step. So I have a training data set, test data set. We already split 80-20 or whatever it is. So the standard scaler should take all the now in the training set. It should see all the features, go and then evaluate the mean and standard deviation, apply on
which
each
it
and
does
every
through
point
fit.
for that.
Yeah.
Yeah, for that
Yeah.
fit. This is
Yeah.
test training is finished. When it comes to test, it should do the same thing, right?
No, because see,
Why we don't
what is
do fit in the what will happen if we do fit for the test also?
it has to do with, again, the term is data leakage. So it has some data leakage. It has something to do with how things work in practice. So you are going to deploy your model today, and whatever new data comes tomorrow, your model should predict well on that. Okay. Does that premise sound okay to you? You have built a model, you have deployed, you have released that model, and whenever they bring in new data tomorrow, it has to make the right predictions. That is the general sort of setup.
Yes, yes.
Now, whatever data is coming tomorrow, you don't have the entire information about it, right? You'll only get the data like tomorrow, so you don't know beforehand how it is. And this transformation has to be based on what we have learned for the training data, because your model is also dependent on what it has seen on the training data. So whatever changes you make on your test data should be subject to what it has learned while training. So it does the transformation, but it makes use of the same objects which were learned as a part of the training data. Is that okay? Because then if you were to separately do fit transform, it is like doing an entirely different kind of a scaling setup, a different kind of a pre-processing setup.
Okay, it also takes care of the training parameters and then do the.
Yeah, so it basically learns only from the training phase, and whatever is learned in the training phase is now used to make changes in the test phase. So from test phase, we don't learn anything new. We cannot learn anything new. We just have to transform the given data into the desired form and then make predictions out of it. If it's not clear, we'll take it up again sometime.
Thank
now
you.
we'll just finish, we'll go through this. But yeah, with this exercise, we saw that whether you scaled or whether from even if you did not scale, the values that we got 70, 49, 42, 79. This is again the same 70, 49, 42, 79. So scaling did not impact decision tree at all. Now let's try a different. We'll try changing some of the settings. Let me call it model C3 is equal to decision tree classifier random state equal to 42. And let's try and give class weights this time. So what is the value that class weight takes? Do we see anything? Class weight. Class weight. Okay, so there is balanced. So yeah, so balance can be used to wait for this. So let's change the class weight parameter. Class weight or weights? Class weight. So class weight is equal to balanced. Okay, so our model 3 is ready. So we'll use it to train. Model 3.fit transform. Again, it's the same thing.
So it's model 3 and not fit transform, only fit.
You're right. It's model So now we have trained a model. This time we've changed the parameter to balanced. Model 3 dot predict. Next test. Let me call it y equal to. And we have classification report y test y print. Have we reversed it by any chance? Let's actually just check. We go here, classification report. So y true comma y print. So y true comma y print is there. Yeah, do we see an improvement? Let's put the previous one on the side by side. Is there an improvement?
Yes, sir.
Yeah, right. So there is a very slight improvement, but it is still present. So the precision, recall, F1 score, all of them have slightly increased, and so has the accuracy overall. So that is a good positive. So next, let us do one more change to this. Let us try doing some hyperparameter tuning. This might take some time, so let us have this as the last thing that we will for today. So param grid is equal to, what are some parameters we can try? So these are your options again.
Length of the height of the tree.
Right. So these are the things that we have. We have criterion, splitter, depth, minimum sample split, and so on. So we'll give a few of them. So let's start with what you suggested. You suggested max depth, right? Max depth. And let's give max depth as one very simple 1, 3, 5, 10. And let's give what else. We'll try the two criterion. So criterion will go with Gini and entropy. Then what else? We'll give minimum sample split.
So how does criterion affect model performance? Because these are just used for the internal nodes split only.
Yeah, so this decides how the tree ends up getting created, right? Whether we use Gini as a criterion or whether we use entropy as a criterion, it will decide how the tree ends up being created.
Okay, so means these criterion also affect the performance of hardware.
Yeah, the criterion also can affect.
Okay, okay.
So minimum sample leaf, let's have this as a master. Correctly. The model is classifier. State. What is it? State balanced. Then we'll give param grid. Let's say cross validation. Should we give anything else? Is this
There
correct? Is there
we are
something
not
missing?
getting any score like.
Yeah, scoring metric, we'll leave it at the default. It's accuracy this time. Okay, let's maybe try some good F1 score. It's okay, let it be accuracy for this. You can experiment with F1 score. So let me go with exchange and right. I think I need to import grid set CV, right? Which one is grid set CV present? Model selection. From the scalar or model selection. Grid set CV. Okay, so it is hitting a lot of folds. So this scores you can see because of verbose parameter that I've used. It turns out I think it has built. That was very fast. Okay, so now let us see the parameters. Let's given this as the best parameters. So we can get the best model out of it. So how do I get the best model out of this?
Best
What is the attribute? Sorry?
estimated also.
Right. So model 4 is equal to this. Now let's hide. We do model 4 dot set range from our right range. Is there a question?
So if we directly use the grid variable, so that also predict using the best parameters.
Yes, you can use that. You can directly predict with it. If you want to just get a separate one out of it, then you can go for this.
Okay.
Yeah. So let's call this y grid model 4 dot predict. Again, we have our classification code. Y grid 3. Not that much of an improvement. We have pretty much the same thing, I guess, that we have got. Let us see if we can hide output. So previously also the score was pretty much same. It's probably decreased in fact. Okay, the recall is higher this time, but the accuracy is down. The other metrics seem to be doing okay. Is this fine? Any questions? Okay. So all right. So with that, we have tried out different variants within the decision tree setup itself. We did some hyperparameter tuning, some changes here. And now ideally with each of these, I want you to put your analysis as well. By doing hyperparameter tuning, did the score improve or not? When we tried scaling, did things change or not? When we went for class setting as balanced, what happened? So basically all this analysis has to come in your notebook. So this was decision tree. The one other small topic that we have in this week is the different evaluation metrics. We'll take it up in the next session. So that is also going to be a shorter session. So any questions on what we discussed so far today? No questions? Okay then. So in that case, as I said, work on this problem statement, work on this Kaggle competition. It should give you a lot of practice. It should prepare you for working with these data sets. And if you have any questions, issues with that, we can again take it up in the next session. We'll go through your notebooks. So try and spend some time on this today. As you saw, it doesn't take much time to write this. Yes, Karthikeyan.
Actually, I don't have any questions on this session. But this
Yeah.
OPP, there is something they say some calculations and all. There is an email came for the OPP calculation.
Okay. When did you receive the email?
I think I received it today. I think today or yesterday. I'm not too sure. I think yeah.
Okay.
They say there is a mock and then some portion. There is some calculation. They say 60-40 and then.
Yeah, I think, yeah, so that is with respect to those who had an issue with the Gmate issue. So the team is verifying all those people who had an issue. So for that, they are modifying some things. Okay, so
And
that
this and there is the mentioning this email was mentioning about some mock OPP. Is that
Yeah.
mock OPP online or it'll be happening same like our normal OPP or
No,
it
it
is
is.
just
I think the mock OPP was. Yeah, I'll actually get back to you on this on Thursday. Okay, I've not seen that mail yet, so I'll just get back to you on this on Thursday.
okay, because I just want to understand this mock OPP will be so online proctored or it will be
Yeah,
normal.
yeah, I get what you're saying. I'll just check with the team and get back.
Okay.
Yes, Kian Prakash.
So I have doubt regarding the competition. So, like if our model is not performing well, we have tried all the uh, different kind of algorithms and all. So, sir, can we use uh, for the competition? Can we use different similar data set to train our model and then
Yeah, yeah.
submit prediction?
Yeah, so you can do that. I wouldn't guarantee that your scores are going to improve a lot. But as you can see in this playground competition, they link to the original data set as well. So
Yes.
that just means you can take that data, you can try to combine it with this, and that way you'll have a bigger data set. So some of the other approaches that tend to happen in practice is they try to artificially generate some samples, which is like a oversampling. So that way with the bigger data set, they try something. Then, like you said, they can also see some other data, they can create good features out of it and transfer whatever they've learned to this project. All these are valid approaches.
Okay, sir.
Yes, Bhavna, please go ahead.
Yes, sir. I have two doubts. First one, you spoke about Kaggle competition. So we make in IT domain whatever email I have.
Yeah, that is fine. You can use either of them. You can use your personal ID also, or you can use the IITM domain ID also. Either of them should be fine. There are no issues.
The second question is about yesterday I did graded assignment week 8 where there is some MNS data set. When we doing coding on that, they took time too much, like 5 minutes to run the whole code.
5 minutes is totally fine. 5 minutes is valid. So
it's okay, but we want to know about OPP. In OPP too, you give this type of data, like
that will be taken care of.
time, too much time.
The time will be considered beforehand for the OPP.
Yeah, for one question it happened. Only for one question.
Yeah, so I think it will even be mentioned in the question paper as well that it might take some time depending on the model. So you don't need to worry about it. So the thing is, when you do a bigger project, even say in your MLP project, what you'll end up seeing is some of these models take like 3 to 4 hours to train at the minimum. So that time you'll just have to keep it running in your system and you can come back after a few hours, especially when you're doing hyperparameter tuning on models like SVM or say random forest. So they end up taking hours and hours together. So that will only increase when you go to deep learning based models. But yeah, that is a topic for another time. So you don't have to worry about the system taking time.
But my question regarding to OPP.
Yeah,
that's-
OPP, like I said, again, there also you don't need to worry. It will be accounted for. You'll have sufficient time as long as you have practiced beforehand. The model taking time will not be an issue for you.
Okay, sir.
All right. Okay. Then anybody else? Any other questions?
Sir, I have a completely off-topic doubt regarding the companies and all. Can I ask?
Yeah. Please go ahead.
Okay, so as I have